let's get back into our home energy controller build. There's a few things we need to add to improve the overall system elegance. First, let's add the room where the service panel monitor is installed as an area within Home Assistant. It's best to create these areas as needed. It's sometimes nice to restart the Home Assistant server from within Home Assistant. Our simplified installation glazed over a few programming steps. In the alternate version of the install, the computer would require a command line interface command that you type into the computer in order to start the system up. In this case, I want to populate Grafana with energy data and create an InfluxDB database. And those may need a system restart after installation in order for the data to populate. When I pull up InfluxDB, it still isn't working, and I suspect it's because I skipped an instruction which told me to edit the configuration YAML file for Home Assistant. This is another file which is hidden outside of the Home Assistant user interface. However, I installed a configurator add-on within Hasio, which allows me to edit the configuration.yaml file from within Home Assistant. Otherwise, I would have to use a command line. It gets a little bit more technical. So I added in the InfluxDB code snippet into the configuration.yaml file using the configurator add-on, and then I restart the Home Assistant server. So now that I've given Home Assistant the ability to recognize InfluxDB by editing the configuration.yaml file, when I go to make a Grafana query, my Home Assistant entities are available. So what can I do with this information? The obvious choice is to create an energy graph for my house. Let's start by graphing the energy meter. I do this by creating a dashboard within Grafana. I need to select the data source for the graph. Home Assistant is a database option because of our previous efforts. So the query is a formula that then gets displayed on the graph. So starting out, change nothing about the query that's presented. Instead, just add to it. So we need to add a variable to the query formula. And so I add a power entity for the whole household, which is that primary energy meter we registered in Home Assistant from earlier. Although the data still looks incomplete. Sometimes with these devices, things appear to be plug and play, but they still need some slight programming modification to fit a specific communication need. For example, a Z-Wave network can support over 250 Z-Wave devices at once, but a single energy monitor reporting its data every 10 seconds can take up 20% of the Z-Wave bandwidth capacity, at which point the network does not function well if it's exceeded. But for our needs, we need that granular 10-second energy data because we use it for our energy monitor and we use it for our load controls. And so, we need that granular data. But something still doesn't look right about the graph. And I go into the Z-Wave configuration panel to inspect the energy monitor device specific configuration settings. This is a Z-Wave device, so it will be in the Z-Wave node configuration settings menu. So I could get further into the technical detail of what every individual byte of data represents. But to solve this problem instead, I perform a Google search on what to enter into these settings because inevitably there's someone else out there installing the exact same energy meter onto the exact same Raspberry Pi within Home Assistant who's probably solved the problem already. And often you can find your solutions just through the message forms. And the solution turned out to basically find the reporting settings within the device configurations and set them to, a 5 or 10 second reporting period. Some of these devices were reporting by every 2 minutes instead of every 5 to 10 seconds, and that was causing our graph to look weird. So I then set the settings to 5 seconds, and then on Grafana, I graph to a 10-second interval, and all of a sudden the graph shows a much higher degree of resolution. So I could spend a good bit of time customizing this graph as well as inputting all of the smart home devices on the platform, which are energy sensing. For example, the wall plug used to control the dehumidifier will often have an energy sensing option associated with it, and maybe that costs a few dollars more than the smart plug without such feature, but it'll tell us how much energy is specifically being used by the dehumidifier, which is nice because all the service panel monitor tells us is the energy use for the entire building. So our graph can include all of those factors, and it can also be uploaded to the internet, which I use to embed on my website, community.solar, but also to embed on my Home Assistant build main front page, so I don't have to go into Grafana within Home Assistant to see what's going on. So let's clean up our Home Assistant main view in the overview section by taking control of the overview page. I don't want my media players to be the first thing I see. I want a display that reflects my home energy controller. So I create a new tab for the media players to move on to. This is called a new view by Home Assistant. And then I select the right option to move all of these card entities on this overview page. I select the right option to move them onto the new view, that media player tab I just created. I'll also take the web link of my energy monitoring graph and embed it into the overview as an iframe, which is essentially taking an offsite website and displaying it within the Home Assistant platform. To clean up and remove some of these entities that had been auto-created, I use the code editor, which gives me a behind-the-scenes look at some of the code. And sometimes this can be easier or quicker to use than the visual interface. So my energy controller interface is now complete with some automations programmed in.